factor so it works. Just to let you know, the way I do it, if you guys factor any other ways, because your teacher taught you previously, that is A-okay with me. I'm going to show you a way that works every single time. Okay? Is it a little bit more is it longer and tedious? Yes, it is. Okay? But it will work every time. So, can anybody tell me what x squared minus 6x minus 7? How would I factor that? You guys know what factoring means first off? The two hippo bugs, right? They look like hippo bugs. Doesn't that look like a hippo bug? No? Okay. It looks like a hippo butt. Okay. Anybody helping me out here? Want to help me? They can do it in their head, because this is pretty much an in-head one. The x goes here, and the x goes here, right? And then we have a negative 7, and as Kenzie said, and a plus 1. What's the factors of 7 that get us to 6? Negative 7 and 1. Okay? That's very simple. Go ahead and do it. What do you mean, like sign change?
Because, like, you would take any alternative to, is it just what you mean x?
So, like, if I have, like, x squared minus 5x plus 6.
Well, just like those same numbers, the negative 7 and the plus 1, they change.
How do I know which one to put the negative with? That's maybe what you're asking. Okay. Notice, this has to be a negative 6. So if I did this a positive 7 and a negative 1, that'd give me a positive 6. So right here, somebody help me out. What's the factors of 6 to get me negative 5? 6 and 1, that does get me there, but notice when I times 6 and 1, I have to get a positive, right? And so if I did that, that'd add to be 7. Negative 2, negative 3. That's all simple and happy-go-lucky times, right? That's if that leading coefficient's 1 and it factors 90, correct? Okay, let me show you. Now I'm going to show you a way, like I said, I'm going to do this one my way. And once again, the reason why I show it this way, because it doesn't matter if your leading coefficient is 1, a 10, a negative 4, whatever it works every time. Okay, does that make sense? But, is there obviously some easier ways? Yes. Can you do those easier ways? More than welcome. Okay? I would just like to give you a way that you can factor. Okay? For a triangle. What you do is take this front number. What's that front number? It is a 1. I go ahead and multiply it to the back, which would be a positive 6. What are the factors of 6? You want to start off right here really quick? 1 and 6. 2 and 3. Notice 3 is on the other side, so that shows me that there's all the factors that I can do. 1, 2, and 3. Yeah, my other term is on the other side. It shows that there's no more factors. I suggest you write down all the factors, because then you don't lose the one that gets you the middle number. Okay? Notice, if something is positive on the end, that means two numbers were times to get to a positive 6, right? So therefore, these two numbers have to be the same sign. Either have to be both negative, there they need to be both positive. In our case, we look to here, and it tells us that they're both going to be negative. Okay? What this tells me here is this is a positive 6, so therefore I add. That's 7, that's 5. Which pair am I going to use? 2 and the 3, right? Does that make sense to everyone? Anybody have a question? Okay, so then I rewrite it. Okay, this is called x squared minus 2x minus 3x plus 6. Now I always have questions. Mr. Roberts, does it matter which order I do these? It will not. Only thing that would do is change your binomials, like to be x minus 2, x minus 3. If you switched them, it'd be x minus 3, x minus 2. Just the commutative property, because we use the commutative property here. Does that make sense to everyone? Okay. So, like I showed you yesterday, this is kind of why it's important to know how to go ahead and multiply, distribute with that one binomial difference here. Let me write that number. That in there. Everybody see that? What do these guys have in common? A 3, but because this guy is negative, if your first term or third term is ever negative, you're going to pull out a negative, okay? okay? So I'm going to plot the negative. But then that gives me a what? X minus 2, and these have to be the same. What does this look like, ladies and gentlemen? This looks like what I showed you yesterday, huh? Where we had that binomial distributed into the other binomial, correct? So we pull out that binomial, and what was the leftover binomial? Okay. There are tons of ways. Want to know how we were taught to do this when I was young? It's called guess and check. All we always did, we had to go right to the hippo butts, right? And we were like, how do we get to x squared? Oh, we know an x and an x. Okay, what's the factors of 6? Oh, there's either 1 and a 6, so I'd have to do a -1, -6. That doesn't make sense, so I don't do that one. Could you imagine trying it this way? Now imagine with this guy being a 2 out front, your leading coefficient, or a 9. Okay, that could be a 9x times an x, that could be a 3x times a 3x. You know what I'm saying? That's how I was taught. So, I struggled with this when I very first learned it. I learned it in college, tutoring. I'm like, why the heck are they teaching these people this silly way? But, once again, after you factor a lot, this becomes second nature. Okay, so if you can find the quicker way, please use it. That's all I'm saying. But you need to understand different ways to use it. Okay? Agree with me on that? If you can factor easily, go ahead and do that. I'm going to give you another one. So let's try a 10x squared you can factor whatever way you want. I'm going to show you my way. Okay, so there's a triangle, right? Okay, so this, how many of you guys were taught anyway guessing and check? I don't think that way is taught anymore. But you're more than welcome to try. I know Miss Merkley or Miss Spangler, I can't remember, did this X thing the bigger. I don't really know how that works. If you want to go with it, go with it. That's fine. Okay? Once again, here's my way. What's that? -40. So if it's a negative, what are you going to do to these two numbers? You're going to subtract them. So I have 1 and 40. Give me the next one. 2 and 20. I ask every number until it wraps around. Does 3 go? No. 4 and 10. 5. 6. 7. 8's on the other side. That shows that I've used every factor. As soon as you wrap around, that shows you used every factor. Notice I didn't skip one number, did I? I asked every single one. Okay? Does that make sense? Which pair am I going to use? 5, right? Because that gets me to be the 3. So how do you know which one? Well, you're going to subtract. So 5 minus 8 or 8 minus 5. You just got to figure out which one is the middle number. So therefore, 10x squared minus 5x plus 8x minus 4. Now the whole thing in math, guys, we don't want to make our whole new equation. Did I change the value from the top to the second one down? No, I just rearranged it, right? It looks exactly the same. It's just unsimplified, right? But notice 5x, negative 5x plus 8x is still 3x. So I didn't change the value. I just made it look different. Okay? Once again, we factor by grouping. What's the front 2 guys have in common? Front 2 have a 5x, right? I'm left with a 2x minus 1. Everybody good there? What do these guys have in common? Positive. Always look at the third term. If he's positive, you're going to pull out a positive. If he's negative, you'll pull out a negative. Positive 4. 2x minus 1. These better be the same. If they're not the same, guess what? You did something wrong. Okay, because you wouldn't be able to do the next step if they're not the same, right? So therefore, I pull out the 2x minus 1. What's left over again? So, how do I know how this is my last factor? Okay, so once again, I went 1, 2. I asked myself, does 3 go into 4? Who said that? 4, 5. I asked myself 6. I asked myself 7. Notice here's 5, 6, 57. I wrap around 8's on the other side, that shows the left half. Does that make sense? Yes, sir.
How do you do that last?
No problem. Same thing? Okay.
Yeah.
Do you remember how yesterday I showed you guys the factor? Okay? So, hold on. I'm going to show you guys this from yesterday. So remember, I can take this binomial and multiply it into both, right? The same thing. So that's 5x times 2x minus 1 plus 4 times 2x minus 1. You remember us doing that yesterday? Were you comfortable going from here to here? Okay? That was yesterday. I took this binomial and I times into him. Took this binomial and I times into him. Right? You with me? Okay. With that being said, do the same thing backwards. I take this binomial out. Let me ask you this one question. Nicole. If I had 5xa plus 4a, what do those guys have? So what would you factor out? What would be left over? 5xa plus 4a. See that? The exact same thing. This is a number. You guys got to think of a binomial as a number. So I pull out that number, right? 2x minus 1. And what's left over? 5x. Yes, sir. Yeah. Okay. Everybody with me? You feel comfy? We're going to get a little deeper now. Okay? Next problem. Oh. By the way, sorry. That's probably part of the lesson. Down. Let's imagine this was set equal to y at the beginning. And I'm going to ask you for the x-intercept. Or f of x, whatever we want to call it, right? Okay? What would be x-intercept mean? What's the definition of x-intercepts? Go ahead. They are the x-intercepts. Does it always have to be of a parabola? In this case, it is a parabola, right? But on a line has an x-intercept, correct? Right? Okay. An x-intercept is when the graph crosses the x-axis. They are also called roots as well, and zeros, exactly. Okay? They are called zeros and roots as well. An x-intercept, once again, is when y or f of x is 0. So if you are timesing, like what we are here, how do we get something to be 0? Well, we find the x value that makes this guy 0, right? Or the x value that makes this guy 0. Right? And that's where the graph would be 0. So what do? We say, okay, we just set it equal to 0. Set it equal to 0. You guys remember doing this at one point? So this would be 2x equals 1 or x equals half. And x would equal negative 4/5. That's exactly what those values are. Okay? Those would be the x-intercepts or the zeros of that equation. That's the value that would make it 0. Okay? So, how does this help us? How can this also help me graph a polynomial? First, what can anybody tell me this polynomial, what the difference all the way at the top? So 10x squared plus 2x plus 3x minus 4. Okay? If I asked you to graph this, just a sketch, how could you do it? Well, there we go. Here's a half, there's 1, so half's roughly right there, right? Here's negative 1, negative 4 goes roughly right there. Everybody see that? You okay with that? What is the end behavior of 10x squared plus 3x minus 4? Show me with your arm. So watch what we have to do. Come down. Okay. We hit the 0. Now notice, when we come up here a little bit, what's the power on this guy? 1. Power on this guy. Those powers are what is called its multiplicity. Okay? So these are multiplicity of 1. Okay? So meaning that this is only considered 1, 0, because there is what we call the fundamental theorem of algebra. If this is an x squared, guess how many zeros you're going to have? 2, for sure. If it's x to the 100th, how many zeros are you going to have? You're and I have 100. Are they always real zeros? No, they could be imaginary, but they're still considered a zero. Okay? That's what the fundamental theorem of algebra is. Okay? And when I go ahead and find my zeros, notice I have this guy and this guy. The multiplicity should add up to be the power. 1 plus 1 is 2. Does that make sense to everybody? Okay. So, just to let you know, please write this in your notes. If you have an odd multiplicity, you are going to cross through the zero. If you have an odd multiplicity, you are going to cross through the zero. I'll explain what a crossing through the zero means in just one second. Nope, just on this guy. So notice, see how this guy has an odd multiplicity and as this guy has an odd multiplicity? So at that zero, we are going to cross through that. Okay? Alright. So, this was negative 4/5. What was the multiplicity on the root, or the binomial that gave me negative 4/5? It was raised to the 1. Is that an odd or an even? Odd. So guess what we do? We cross. So therefore we come through from positive. What I mean from crossing, you go from positive to negative. And somewhere I got to come back up here, so I'm going to come back up. With the 1/2, was he an even or odd multiplicity? Odd, so are we going to cross, or we haven't talked about the other yet, we are going to bounce across, we are going to cross. And that's roughly a good rough sketch of that graph, right? Does it have the end behavior that we expected? It does, doesn't it? Does it have the shape that we expected? Kind of a U shape, right? It does. Does it have its two zeros? It does. Okay. I'm going to call U x squared. So this guy, instead of x squared, what can I write for? What is x to the 4th? Isn't that x squared squared? So isn't that U squared? You see what I did there? I just changed. So now, doesn't this look exactly like what we just barely did? This one didn't, but by substituting the x squared for U, I can make it something familiar to me, right? Everybody there with me? Okay, so let's just factor him. This one's really easy to just do with hippo butts really quick. How do we get a U squared? A U and a 2, right? How do we get factors of 36 that get me to be 13? Should we do the chart? Sure. 1, 36, 2, 18, 3, 12, 4, 9, 5 can't go, 6 and 6. Which one adds to be 4 and 9? So I know this guy's going to be a negative or negative 9. Is everybody good there? Does everybody understand how I got that? Yes, no, maybe so? All right. Okay. So, but what is U? Oh, go ahead, sir. Okay, that's the thing. Are we done yet? No. So now, what is U? So now we can rearrange this and say x squared minus 4, x squared minus 9. Does anybody remember what these guys are called? They're special. Called difference of squares. Does anybody remember what difference of squares factors into from last year? You probably sure did. They don't go to square roots. Why? They could go square roots, but if I factored this is another hippo butt, right? You guys don't want me to call them hippo butts. They're perfect squares. X squared is a perfect square. 4 is a perfect square, right? Difference means subtract. Okay, what's the factors of 4 that subtract from 0? Negative 2. Difference of squares always factor into conjugates. You guys remember the word conjugate? Same thing, different sign, right? So what does this guy factor into? X minus 3 and x plus 3. But that is also a difference of squares, correct? Everybody see that? Everybody with me? What are my zeros, or my x-intercepts? The x-intercepts would be, what value makes him 0? 2. So I'm going to do plus or minus, right? What value makes him 0? 3. Negative 2. Okay, what is the multiplicity on all of my zeros? 1, 1, 1, 1, right? Everybody understand that? Okay. Exactly. So notice 1, 2, 3, 4. And how many zeros could I have had? 4, because it was x to the 4th, right? Everybody there with me? Okay, so now we're going to graph it. So I'm going to go ahead and graph this really quick. 1, 2, 3, 1, 2, 3. And once again, I'm not asking you to be accurate, I'm asking you to sketch. Okay? So once again, where are my zeros? 3, 2, negative 2, 3. Okay? Anybody have a question? Okay. Yes, sir. Intercept? Yes, it is. So we know he's going to cross down here at negative 2. Okay? All right. Once again, I'm really not, you could use that if you want to be a little bit more accurate, more about it. Okay? All right. End behavior of x to the 4th minus 13x plus 36. Arm, show me. Right? Everybody understand that? So that helps us. That tells us he's going to be coming down. When I come to negative 3, what was his multiplicity? Am I going to cross through it, or am I going to bounce? By the way, did I get you guys on bounces, by the way? If it is an even multiplicity, you're going to bounce at that intercept or 0. When I mean by the bounce, what happens is, like, see how he's decreasing? He'd hit the 0 and he'd bounce back up. You'd stay above or below whatever you were at for your increasing even. Okay? Does that make sense what I'm saying by that? So are we going to be crossing or are we going to be bouncing? We're going to be crossing on all of them because they're all odd multiplicities. Okay? Was it a positive 36 or a negative 36? Oh, I was going to say, that makes more sense. So that point right there is 36. Yeah. Makes me feel better. Okay? Once again, that's just a rough sketch. Everybody see that? The end behavior? Okay, once again, what does anything raised to an even power look like? The highest power of a degree of even. Remember, how do I know if he goes down? If there's a negative leading coefficient, right? Remember, this is odd. If he has a negative leading coefficient, okay? Everybody there with me? Okay, so I'm going to do something just a little bit different. This time, okay, actually this will work. This will be fine. Okay, we're going to go ahead and graph this guy by using my zeros and my end behavior. Okay? Hold on, let's make this an F. Make those all F. All right, what are they first? Oh, let's do. All right, what do they all have in common? X what? They also all have a negative. Let's pull out here. Does that make sense? Flip that over. X squared plus 4x minus, plus, right? Everybody there with me? What can we do with it? Factor, yeah. So you can go right into it. Factors of 3 that give me to 4. It's pretty simple. There's only one factor of 3. 1 of 3, right? So there's negative x squared times x plus 3 x plus 1. Okay. What's the power on here? 1 my zeros. What value makes this graph 0? Negative 3. Does everybody see this, guys? Negative 3. Any others? What value makes 30? 0. If I plug 0 in for x squared, doesn't this make this whole thing 0? Okay, but what is 0's multiplicity? It's a 2, huh? Because that's being something squared. He has an even multiplicity. Okay, does that make sense? Okay, so we come down here. Negative 3. Negative 1. Okay, we need to know what our end behavior looks like. What does it look like? Go down. It's a negative x to the 4th, huh? Does that make sense to everyone? We good with that? So we're going to start coming from the down. When I get to this guy, what was negative 3's multiplicity? It was 1, so therefore we cross or bound? Cross. Negative 1, cross or bound? Cross. 0, cross or bound? You see how that works? Pretty simple, huh? Okay. Please, once again, guys, as I said in the very first day, we are starting to use calculators today. Okay? I wish I could show you exactly on the board, but I'm going to have to explain it. Okay? There is going to be a high point right here somewhere. Now, is my graph accurate? No. I sketched it, correct? Okay, there's going to be a low point here. I want to find those points. Just like yesterday, on the graph that I gave you that hump and that low hump, right, for the bell curve. Okay, we need to find those points so we can find out where the graph is increasing and decreasing. So everybody go, if you have your calculator today, go ahead and go y equals. If not, I would suggest you use time implicit. Okay? You're more than welcome to use the Wabbit. It is free. But at the same time, what did I also explain? You're not allowed to use that on the test if it's on your phone or an iPod. Does that make sense? Because we've had kids jump on that later and do other things and say, oh, how do I solve this problem on the internet? And that's why that's not allowed. Okay? Okay. All right. So, go into your y equals. It was negative, so we're going to go negative. Remember, use the negative button. X caret is how we get to the 4th power, right? X caret to the 4th. I think it was negative x to the 4th minus 4x cubed minus 3x squared, wasn't it? Okay. So, we go ahead and have that. Yep, you're going to plug that in to the y equals. After you have found the graph, you're going to go ahead and hit your second button. And over to the trace or the calculate, see if it's above it, it says calculate, correct? On the very top, 4th one over. Hit that, and then we'll notice it says max, correct? Is I think the 3rd one down or 4th one down? The 4th one down? Let's see. Yeah, that's it. Your axes are not. Not the top. Because your level, yours is that. Your got a picture in the background. How the hell did you get rid of that picture? Anyway, okay, so it's not exactly. This is a sketch, correct? It might not go down this low. It was a sketch for me. I just went down. Yes. Okay. All Alright, so what I want you to do is, once again, hit second calculate. Go to max or min. Okay? Max or min? Then I want to find the max. So what it tells me is left bound, right? So what I'm going to do is put my star somewhere over here, because that is to the left of where the maximum is. Does that make sense? And then, after you hit enter, what does it say? Right bound. So then you come over here, and you push enter. Does that make sense? You're pushing on your cursor. Does anybody find on this point for me yet? Now hit, and then it tells you to guess, correct? Hit enter. Just hit enter. Doesn't matter. And what is the coordinate point? Roughly, give me the x value first. That's good. 3/4. We'll just say that for right now. Oh no, whatever. I don't even care about the comma because that doesn't help me with my increasing or decreasing. Because when I talk about increasing or decreasing, I talk about the x values that are helping me with my increasing and decreasing. Does that make sense? Okay. Then we got to find this low point. Now your guys' graph doesn't have an obvious low, so we might have to zoom in. So you hit your zoom button and zoom in a little bit. Okay? Well, hit the thing that allows you to go back. Okay, now, so you're going to go second count, and then go find the minimum. If you zoom in on the regular scale, you'll see that low point. At least on Weston's it did. Hit enter. You got it? You don't have to. I didn't really see it as well, but you could. Zoom out, hit the zoom button. And then, yep, and then you hit enter, and then you hit enter again. I don't know, I haven't looked at it yet. What do we got for this x value of the low point? Let's make sure. Negative 0.63. Do I have a second on that? Okay. Now, if you don't have a calculator today and you want some help, or if you have some help, once again, I am waiting for mine so I can actually show you on my board. That'll help us a lot more that you guys actually see the buttons I'm pushing. Okay, that'll help out a lot. Okay? But once again, if you have problems with your calculator, please come visit me and I'll help you out. If you don't have one, you need to start getting one. Okay? Alright, so where is this graph increasing from? And then notice there's there's one more point right here, but it should hit 0 right there, right, and then back down. So notice this 0.00, you can find your increasing. Give me one sec, guys. Your increasing is this portion and this portion, isn't it? And then your decreasing is this portion and this portion. Okay, let me give you your homework before you leave. So you would write negative infinity to negative 2.34, comma, or union, negative 0.6.